Magnitudes are something that often confuses people. Hopefully after this video you'll understand it a little bit better. The important thing is to remember the number line. Remember that for historical reasons, the magnitude scale got a little unwieldy, and there's nothing I can really do about that. All I can do is try to help you understand the system that we have today. Remember that the more negative the number, the brighter the object appears. So the sun has the highest apparent magnitude at -25. The more positive the magnitude, the dimmer the object. So objects seen by the Hubble Space Telescope, for example, might have an apparent magnitude of +25 or +28 or some very large number like that. As you move to the left, as you move towards negative numbers, the brighter the object appears. And as you move to the right towards the positive numbers, the dimmer the object appears. But the important thing is how many times brighter things look as you move from one magnitude to the next. As you go towards the left, towards the more negative numbers, with each magnitude you move to the left, the apparent brightness goes up by a factor of 2.5 times. That is a number that you need to know, because there is no formula per se for figuring out differences in brightness. You just have to know that for every magnitude you go up in brightness 2.5 times. So, what is brighter, a magnitude 2 or a magnitude 5 star? Well, which one is going to be closer to the left-hand side of the number line? Which one is closer to the negative numbers? Clearly, that's a magnitude 2. So we know that a magnitude 2 star appears brighter than a magnitude 5 star. But how many times brighter? To answer that question, we need to figure out how many magnitudes we've moved. So how many magnitudes are there between magnitude 2 and magnitude 3? The answer, of course, is that there are 3 magnitudes difference. And remember, for each magnitude, we have a brightness difference of 2.5 times. So, since we have 3 magnitudes difference, we have to multiply 2.5 times 2.5 times 2.5. We have 3 of them, 1 for each magnitude. And this comes out to be 15.6. So if you multiply 2.5 times 2.5 times 2.5, that's the answer. Now there is a shorter way to do that. That's to know that for every magnitude, we have a difference of 2.5 times. And so rather than write this out 2.5 times 2.5 times 2.5, we could just take 2.5 to the 3rd power. Why to the 3rd power? Because we have 3 magnitudes difference, and the answer will come out exactly the same as we did before, 15.6. So let's do another one. What is brighter, a magnitude 7 or a magnitude 2 star? Well, the magnitude 2 is closer to the negative side of the number line, so that's going to be the brighter star. Well, how much brighter? So how many magnitudes difference do we have between a magnitude 2 and a magnitude 7? The answer is we have 5 magnitudes of difference. So we could do 2.5 times 2.5 times 2.5 times 2.5 times 2.5. Right? We've got 1, 2, 3, 4, 5. And if we do that, we end up with 98. But there is a faster way to do that. We take 2.5 and we raise it to the 5th power. And if we do that, we get back again 98. Here's our last example. What is brighter, a magnitude -1 or a magnitude 3? Well, since a magnitude -1 already has a negative sign, it's certainly going to be brighter than a magnitude 3. But how much brighter? Here, don't get tricked. How many magnitudes in difference are there between a 3 and a -1? Go ahead, it's okay to count on your fingers. I've been known to do it sometimes. We have 4 magnitudes of difference. If you don't understand, go look at the number line. So we have 4 magnitudes difference between a 3 and a -1. So to figure out how much brighter it is, I could do 2.5 times 2.5 times 2.5 times 2.5, or since I'm getting lazy right about now, I'm just going to do 2.5 raised to the 4th power, and 2.5 raised to the 4th power, according to my calculator, is 39. So the answer is that the difference in brightness is a factor of 39.